Hey everyone. So this is the project I wrote in the blog about, and it's a microcontroller ESP32. I used to use Arduino before, but ESP32 comes with Wi-Fi and Bluetooth radio on board, so I don't have to install an external adapter. So now I started using ESP32. It's also more powerful, better memory. So let me zoom it in a little. So this is the microcontroller, and it's connected, powered via USB right now. And in my project, the first thing I did was to test the connection between the phone and the controller. Now, these microcontrollers have a very specific way of communicating. You have to keep track of the bytes, characters, baud rate and everything. So first thing I wanted to do was make sure that I have a very good connection between my phone and the controller. The other thing I wanted to do was always run a heartbeat, meaning it's continuously communicating with the controller and it's telling me what is the uptime. That way, if the communication breaks, this is supposed to shut down and not run any motors. So let's connect. Actually, it is connected. The first thing is I have a beeper that tells me that it's actually connected. This works. Also, LED on, LED off. Once the communication was working, I added controllers for this motor. Now there are two motors, one is for the horizontal panning and the other one is for the vertical pitch control, and both of them are controlled with the controller. A quick warning for the electrical guys: make sure that when you have two separate systems, the motor and the controller and anything else, always run a ground around, so when the controller sends a 3.3 volt signal, the motor needs to know in reference to what, right? What is 3.3? So as when they are on a common ground, they will understand it. Otherwise, it will get what we call floating voltage, which doesn't make sense, right? Is it 3 volts? Is it 3.3 volts? It is 3000, 3.3 volts, who knows, right? So always have a ground wire between them. Anyway, once that was connected, the servo controls were added, and I need to power this thing on. Alright, so this is my servo control, and I'll show you. Cursor created this UI for me, so it was very easy to do this. I didn't really control it because it's an experiment, so I didn't want to make very good looking or efficient UI. It's a very simple scroll back and forth. The next thing I did was, what was the next thing I did? Oh, instead of me having to control this, I added tilt control. So let's go there. Enable. The power keeps turning off. What's wrong with this? You see this? Now you see if it's switching back and forth because the compass on the phone is not very accurate. You know, when you go to Google Maps, it asks you to calibrate your magnetometer because of a lot of interference from around. It gets very confused, so it doesn't know what's going on. And I'll need to power it externally. Let's do this here. For some reason my battery, okay, now this is better. My battery pack is not able to power this, although it's very powerful, so I don't know what's going on. But anyway, the left and right you see is not very accurate, it keeps getting confused. But this is very accurate. Oops, turned off. Okay. Let's do it at a distance. I think the magnetic interference is causing its confusion. You see this? This is, oh, come on, stop it. I'll move further away from it. Yeah, see that? The vertical movement is good because it's based on the gravitational force, but the magnetometer goes crazy anytime I go close to machines. So anyway, the next thing, let me zoom out a little. You're not able to see me. Alright. Okay, let's turn this off. Next thing I did was added camera tracking. So I wanted an object to be tracked using this camera, phone's camera, and then it would send a signal to the controller. Let's try that. Object tracking, switch to the front camera, enable centering, calibrate. Okay, this one is a little right. It's not. Okay, now it's tracking it. It's not perfect, but yeah, it keeps losing me because it's a very rudimentary logic I have. Now, the next thing I did was I said track the object and then move the motor so you are actually following the object. So let's try that. Come back. Alright. Then I'm going to put this here. Okay. Object tracking. Switch. Okay. There you go. Now it's following me. And now it's lost. Come back, come back, come back. Okay. Anyway. So let's take this out. Close. Disconnect. Okay. So the idea behind this project was I built something like this 2 years ago. I was trying to track, as I was flying my paramotor, I wanted this to get the coordinates of my other phone and then calculate where I was in space and then track me and take my photos or whatnot. But then I stopped. I redid the entire project, like I said in my blog, in Cursor, and it took me 1.5 days to finish the whole thing, which was amazing. The other thing is, when I write code, my brain works faster than I can type, so I write very dirty code. If I need something, I write it there, and then I don't build classes, I don't build functions. Eventually I refactor the code, but when I write it really fast. And with Cursor I was able to do it because Cursor did all the ground level work. It built the structure, it built the classes. When I had to build the data structure between the phone and the controller, because you pass byte by byte and then reconstruct it at the destination, then try to read it as a string. All of that was done by Cursor very quickly, and I didn't have to spend a lot of time. So I spent a lot of time thinking. Cursor spent a lot of time actually building the code. So yeah, it was really good experience. Next level would be to add a few more machines and sensors so I don't have to keep correcting it, but seems to be a really good exercise. Yep, thank you.